I'll say a few words about myself. My name's Nick Barnes. I'm a software engineer, a professional software engineer. I run a small consultancy firm up in Cambridge, and I spent several years wasting my time correcting people who are wrong on the internet. I caution everyone to avoid that. About climate science, which has always been an interest of mine for many years, and is the subject of endless, more or less uninformed discussion on the internet still, despite many years of during which one might hope it had improved. This is starting up now, so I'll have to recover my documents. Anyway, and so I thought long and hard, what could I do to use my professional skills in a more constructive way in that field. So I set up the Climate Code Foundation, which is a non-profit, or more accurately a non-revenue organisation to promote the public understanding of climate science by doing software things. There's a list, you can see it on our website. Is that? Yes, here we are. And it became clear after a while that an important focus is on encouraging climate scientists to use more open source software development principles, because science is all about, the average scientist spends 35% of their work time developing software. So I was going to say science is all about software. It's not quite true, but software is very important in science, and scientists receive more or less no professional training in developing software, so they don't know, because no one's told them about the benefits of open source development practices and agile development practices and so on. So there's a lot of work to be done there. And I moved from that into a sort of a sub-project of that, which is Science Code Manifesto. It's the URL, sciencecodemanifesto.org. I encourage you to go there as soon as I finish my talk and endorse the manifesto, which basically argues that the code that is written to support a published piece of research should be published alongside the research. And there are all sorts of hurdles that one should surmount before that's the reality, but the manifesto, the supporting documents of the manifesto, discuss those and how they should be addressed. So anyway, Mark very kindly invited me to talk today. I know nothing at all about audio and music research, so I'll be right up front about that. It's not my field, but I think there are other people here today of whom that's also true. It's nice to be talking to people who I think largely share my views about the importance of code publication. So when I wrote this talk on Monday, it was intended to be polemical and provocative and sort of get people's backs up a bit. If there are people who don't agree with me, then maybe we'll get your backs up, and that's good, and we can discuss it. That's the point. If no one here disagrees with me, then hopefully this will provide ammunition for you to go and convince other people of the same things. 10 Reasons You Must Publish Your Code, that was a title that I came up with off the top of my head when I was invited to come up with the title. When I actually started writing the talk, it started looking more like 10 reasons you really want to publish your code. 10 reasons is a really good idea. Maybe some of them are close to must. We'll see. Okay, so... Oh no, it's done the same thing again. Hold on a second. It keeps wanting to forget my second slide, so I'll just click on... There's a button here somewhere. Here we are. Right, and go back to the slideshow. Slides up here, good. Right, 10 reasons. First reason is review. I'll just say, I put the slides together in a desperate rush yesterday. This is a license everything CC BY. Almost all the content on the right-hand side of the slides is actually stolen off the internet, so it's not licensed CC BY. It's fair use or something. there's some text on the left which belongs to a small amount of text on the left which does actually belong to me and which you're welcome to steal, do whatever you like with. But you know, not so much the things on the right. Some of the things on the right are mine. Right. First reason is review. Peer review, very important in research, and it can be a significant hurdle. And very often reviewers' comments say, "Oh well, you need to say a bit more about your data methods, your data processing. You know, that's a bit skimpy there." And this is usually, you know, alongside other remarks to say, "Well, you need to add this and this and this, and you have to cut something somewhere." We'll get to that in a minute. What sense can it possibly make to write 100 words in a paper saying, "Oh, we use the package which is called this to perform this analysis," where a textual description like that cannot convey the details of the algorithm, the parameters, the configurations of the algorithm that you used. It's without the source code, the text is close to useless. You know, it just gives you sort of a vague hint as to what you did. The reviewers are always going to come back, or very often going to come back and say, "Oh, you know, I don't understand. What was it you actually did?" If you provide the source code, usually not in the paper, no one puts source code in the paper, hardly anyone. There are some journals that provide for that. Supplementary information, somewhere, anywhere on the internet, stick it on GitHub, would be my own personal recommendation. Sign up to GitHub, get your code on there, and link to it from the paper. And then you can have your, you know, couple of sentences saying we used foo, baz, package, and these are the results in here, pretty pictures. Click here, will take you to the actual code that generates those actual pictures from your data. So, and reviewers like that. Increasingly, reviewers like that. As, you know, depends on the reviewer, but it gives them less reason to complain about your paper, which is what you want in peer review. Right? You want to smoothly get to publication. So, review. Oh, images. This is what you can do on GitHub, which is what reviewers do all the time on GitHub. Not paper reviewers, mostly code reviewers. Someone checks in a change to some project. You're going through it. You think, "Oh, that's, you know, I don't think that should be quite like that." You just click on it. Type in your comments. This is what reviewers like in the modern software world. It's very streamlined and efficient. Right, next reason. I need to go a bit faster. Right, reproducibility. Reproducibility. There was a study a few years ago in genomics. It's not a small study, but the results are just entirely plausible to anyone who's looked at reproducibility. They took, I think it was 18 papers from just selected. It was all the papers that had been published in some journal over a period of time in a particular subfield of genomics. And they tried to reproduce the results. And for 14 out of 18 papers, they could not reproduce the results. And most of the problems boiled down to software, essentially. The papers didn't describe, you know, the exact version of which package it was. The data in genomics, almost all the data is open. That's great. You know, it's a terrific field for people who like open data. But a lot of the software is not open. There's a certain amount of use of proprietary software, which is the problem in the first place. But the software that you know, might just be 10 lines of configuration script that you write to drive that software for your research. Doesn't get published, and without that, you can't reproduce the results. So, run my code, set up by Victoria Stodden. If you want to find out about reproducibility, look up Victoria Stodden on the internet. She's awesome. Over here on the left is a picture from IPython Notebook, which I'll say more about if there's time, which is it's a tremendous piece of software, which basically lets you write papers. I mean, among other things you can do, it lets you write papers. This is an example. It's just a randomly selected example. With the code for all of the diagrams, all the data processing and so on, right there in the same digital document as the text of the paper. And then you press go, and it turns it into, you know, via LaTeX, whatever, into PDF and into a web page, which you can go to. You can click on stuff. You can change the text. You can change the parameters. generate different figures. It means you can eliminate the reproducibility hurdle almost entirely. You can go further than IPython Notebook does with virtualization, and some people do that, and that's terrific. I'm all in favour. But essentially, if you want people to be able to reproduce your results, you've got to publish your code. That's the essential point there with reproducibility. I will say one thing, which is that when I first got into this subject, as someone coming from outside science, I'm, as I say, a software engineer, these reasons were not the reasons that I might get onto them at the end of the talk or in conversation over coffee afterwards. What I've found is that these reasons, the ones I'm opening with especially, are the ones which often really motivate working researchers, because they're about the hurdles they face every day. Oh, this bad review came back. Oh, people are complaining that they can't reproduce my work, and so on. So it's interesting to sort of look at these things more from the inside of science than these days. Citations. Everyone loves citations. They're good for everything, right? Or metrics also. There are many metrics that say how awesome you are as a researcher. But citations is an old one and still very highly regarded, very important. How do you get more citations? By putting reusable code into your work. You write some reusable code. You make it available on the internet somehow. Doesn't matter. Institutional repository. I don't care. You link to it from your paper. Or you describe it. Ideally, you describe it in a paper, or you allude to it in a paper. People like your code. Anyone reuses your code, they're going to cite your paper. Often, in many fields, I don't know if it's true in acoustics, because I know nothing about audio music research, there are, in a sort of narrow subdiscipline, there are a few key pieces of software which become normal to use. You don't have to use them, but they're often the sort of the bread and butter of research in that field. If you're using that software in your research, you write a paper, you've got to cite the paper or you ought to cite the paper that describes the software, the original publication that describes the software. Well, hey, citation counts. This guy, Henry Zepper, he's not the best example. He's just the one that came to mind when I was doing the slides yesterday. He's a chemist at Imperial. He works with Peter Murray Rust, who some of you might know, on Blue Obelisk and on CML. He had some key things in chemistry and crystallography. And these, this is from Google Scholar. So the numbers, if you look at other citation indices, you get different numbers. He gets pretty good citation counts because some of his papers describe little bits of software, including way back, one of these, MMDO parameters. That paper alludes to some Fortran that, I believe that's the one, some Fortran that he and his colleagues wrote back in 1978. And it still gets the occasional citation today because it's a definitive piece of code. So, if you like citations, you've got to publish your code. Collaboration. Oh, that's a pretty picture, isn't it? This is a small piece of the GitHub collaboration network, as drawn by a guy called Frank something, who a few years ago, this isn't new data, this is from 2009 or 10. Anyway, not new. The nodes in this graph are people, developers. The links are when they've worked together on a GitHub project. Reusable code generates collaboration. Anyone who reuses your code, they're going to be, in anything beyond a trivial way, they're interested in modifying it, in developing it further. If you're the original developer, they're going to talk to you about that. If there are a lot of people like that, then it may well turn into a project. You become the project leader, de facto, because you're the person who wrote the code and you're the person who understands it best. You get co-author credits, you get conference invitations, job offers. Collaboration is really important in all fields of research, and if you want to collaborate more, a really good way to stimulate that is to publish your source code. Skills. Software carpentry, completely awesome, Eslis. Figuera. He's talking like, it is you talking later. Software carpentry. Yes, skills. Most researchers have got slightly shoddy software skills. This probably isn't true for people here in this room today because today's about software. But if you look at climate scientists, which I do all the time, it's my when I have time to spend on Climate Code Foundation, they're the people I talk to. They've never been trained in software. They can't code their way out of a paper bag. It's not their fault. Training is desperately important. We need a lot more of it. When they start publishing their code, they acquire new skills, some of which are specifically to do with code publication, like GitHub, for instance, or Subversion, or tools that one uses for sharing and collaboration. Some of them, it's simply they brush up, then you naturally brush up your skills at producing things that you're going to show to people. It's a very natural part. Most scientists, but working researchers, are aware that their software skills are not as good as they would like them to be. If you want to improve your skills, an excellent stimulus for that is to start publishing your code. And people are worried about this. I wrote a whole piece from Nature about how people don't like to sort of open up, don't like to open the kimono to show how ghastly their code is. But the fact is that their audience, their peers, share the problem. And in practice, a lot of code out there is really terrible. Once you start opening up and discussing it, you just learn little tricks and little things which make your code better. If you want to make your code better, an excellent stimulus to developing better software skills is to start publishing it. I shan't talk any more about software carpentry apart from say they're completely awesome, and there's a talk later. So, next, right, career. I've never met this guy, Aaron Quinlan. Again, he's just some dude that I searched for bioinformatics on GitHub or something like that. He's just, one of the people who shows up. How awesome is this going to look on his curriculum vitae if he's applying for a job? Right? Hiring committees love this stuff. If he's staying in the field, if he's going for a job out in industry, it's just fantastic, right? He's well, let's see, look. 1,045 contributions to an assortment of projects on GitHub. It's no good. Well, compare that to going to a hiring committee and they say, oh, what's your software experience? You say, oh, yes, I wrote this thing. Where is it? Oh, on some departmental server at my job before last. If you want a lasting contribution to your curriculum vitae, to your career progression as a researcher or as someone who uses software in their day job, one day you might move sideways out of research. Most people do, eventually. If you've published your source code, then you have that, always. That can't be taken away from you by, when it doesn't live at your institution anymore. It lives on the internet. Now, this is a good one. How am I doing? Oh, right. Excellent. Right, reputation. Ooh. Reinhardt and Rogoff. Economists, in 2010, they published an incredibly influential paper entitled something like GDP debt ratio and growth in industrialized economies. And they went on talk shows, and they testified before US Senate hearings, and their paper was waived in Parliament, and etc. Very, very influential. And this is key chart from their paper. You can't read it from back there, it's fine. It looked at post-war industrialized economies and divided them year by year into 4 categories, whether their debt-GDP ratio was below 30%, so 60, 60 to 90, above 90%. And they looked at growth in that year. And they drew this chart. And you can see the average. It's a terrible, terrible chart. Not just, the presentation. Anyway, in the pairs, the left-hand one is the average in that bucket. And you can see it's like flat, and then it falls off a cliff at 90%. See this? See this one there? See this cliff? This chart, this was generated with an Excel spreadsheet. which was published this year. This is the truth over here. This chart. 90% is that line there. You see the cliff? You see how the black line plainly, all the data is really, really crammed up against that line. It's just an obvious trend, right? Yes, of course, the world should follow austerity policies and put hundreds of millions of people out of work and, cause destruction across the global economy. That's a great idea, yeah. Sorry, political moment. As it happens, these guys will be fine. They have very powerful friends. But in general, if there are problems in your code that comes out later, because people can't reproduce, and when eventually people are able to follow it along, they find that bug in your code, that's pretty bad. If your code is out there in the open, bugs get found sooner, fixed sooner, more effectively. Your research is better, your field is better, and you don't get masses of egg on your face. So, if you don't want egg on your face, publish your code. Policies. This is quick and easy. Finch report, the Royal Society thing, NIH. This is open access, really, to the stuff on the right. There's a rapid move, an accelerating move towards more openness in science and research. All kinds of institutions and journals and funding bodies have really strong open access policies now, and they're developing open software policies. Nature and Science have changed their software policies in the last few years, and they're still a bit wishy-washy, but it's getting there. There are journals, biostatistics, I put it up there, there's another. There are computation geosciences, anyway, journals which actually require not merely that you submit your code, which biostatistics has this brilliant kite mark system, which I don't have time to talk about, but that you publish your code to GitHub or to SourceForge or to a named public repository. If you want to publish in those journals or work for that funding, or work at those institutions, you must publish your source code. This is where must. This slide really does have must. If you want that money or that job, you must publish your source code. And so, obviously, it's good for career and all sorts of other things. Preparation. I needed a one-word thing. This is about the future. This is where we're going. Greg Wilson, Software Carpentry, put it very well recently. In the future, scientists won't submit, publish and download papers. They will fork and merge projects. This is where research is going to be. The thing up there is an article I wrote describing my vision of the future, which lots of people are looking the same way. This is a brilliant, brilliant book. If you take away one thing from my talk, buy this book. Michael Nielsen, leading quantum computation guy. He describes how science has changed, is changing, where we're going. It's a lot of it that is to do with citizen cyber science networky things. But it's not directly addressed. Doesn't directly address this point, but it's much of the same stuff is going on. If you want to be ready for the future, start publishing your source code now. Last slide. Reason number 10. Science, dudes! Science is about publication. Scientists publish their methods. That's what scientific publication is about. That's what it's for. That's why we do all this peer review. That's why journals exist. Publish your methods. Isaac Newton, Gottfried Leibniz, big battles about priority on inventing calculus in the 17th century. Henry Oldenburg, amazing guy, spy, etc., first secretary of the Royal Society. This is the birth of science. And what made it science and not alchemy is publication. This is what science is. This is the core. This is the argument, which is rubbish when you talk to working scientists. They're like, oh, but this is terrible. But then this is where I came from, right? You're doing science, publish your work. If you're not publishing your work, that's not science, that's alchemy. Stop it. Thank you.
Okay, we have time for a couple of questions. Brian.
Since you stated that you wanted some sort of controversy or conflict, one thing that I'll ask you about is, this is a change that's happened in the U.S. is we've changed our patent laws to agree with European patent laws, which are first to file as opposed to first to publish.
Yeah.
One side effect of this is, if we do something and we're not exactly sure what's making things work in our code, until we actually figure all that stuff out ourselves and file for a patent, we don't want to publish because, of course, if I put it on GitHub, you could figure it out before me and you get the patent.
Really short version of my answer is that software patents are evil and must be destroyed. I could, if you don't agree with that, that's fine, and I know a lot of people don't. Very few researchers got rich on the back of their ideas. Patents are about protecting ideas. Yeah, patents are about protecting ideas. There's a really huge simplification on intellectual property law, but people progress well in their fields because they have ideas, but not because those ideas are protected somehow. And my interest is in the advance of sort of science and human knowledge and so forth, in which case obviously sharing ideas is the right thing. But if what you're interested in is your career, then the important thing is not that you are able to exercise some economic control over people who want to use your ideas, but that you're recognized as being the person who had those ideas. And so I've been working in software all my life, I've never filed a patent or had any part in filing a software patent. I wouldn't do it. They're just wrong.
Another question.
Yes, I just wanted to follow up from Brian's point here. I was trying to, firstly, let me say I do agree with all 10 reasons. I think the talk is brilliant and certainly does put forward a very strong case, particularly with climate science and things like that. I was keeping in mind the reasons we might not, and I think there's something about the possibility of commercializing research that, if we're accepting funding from research councils, I feel that they expect us to protect the commercial value, and they expect commercial value to come out of this research. If we're going to put those into products, patents are useless, as you said yourself. Software patents doesn't almost exist. So really, all you have is copyright and code protection.
Right.
So I think my question is, how do you combine that with the view of open source and
Right. There are lots of answers here as well. The key tool for protecting your expression of ideas, I don't think ideas deserve protection. I think ideas need to be spread about, as I said earlier. Protecting it for protecting the expression of ideas, copyright is the legal tool, as you say. And all of my work ever, with a few tiny examples which I put into the public domain, is subject to copyright. I have some control over that, or my employers did in some cases, or my clients. And much of it is open source, and by the appropriate choice of license, of open source license, you can do a lot to manage that risk if you see it as a risk. So in particular, the obvious thing is to use the GPL as a GNU General Public License. If you want to constrain proprietary, as opposed to commercial, uses of your work. I have a whole talk on licensing and copyright, but there isn't really time now. Yeah. But the other thing I would say is that if there are really good ideas in your code, then those ideas can be re-implemented for free by anyone, because that's good. That's ideas. What they can't do is just steal your code, just use your code without obeying the terms of whatever your license is. So there are limits to the protection.
Okay, well, I think in order to keep to time, I think if there are any other questions, we can handle them at lunch. So, Nick, thank you very much again.
Thank you.